What happens if you slowly lose interest in everything? Not only hobbies or entertainment, but motivation, curiosity, emotional engagement, and the ability to feel excitement itself begin fading over time. At first, this feels temporary. You assume you are simply tired, distracted, emotionally drained, or unmotivated. But underneath this experience, your brain may be adapting to chronic overstimulation, stress exposure, attentional fragmentation, and reward system dysregulation. Let's begin with dopamine. Dopamine is commonly described as the brain's pleasure chemical, but this description is incomplete. Dopamine is more accurately involved in reward prediction, motivational salience, effort allocation, behavioral reinforcement, and goal-directed action. In other words, dopamine helps the brain decide what matters. When the brain anticipates meaningful reward, dopamine signaling increases attention, motivation, curiosity, and behavioral drive. Under balanced conditions, this system helps humans pursue learning, relationships, exploration, achievement, and emotional engagement. But modern environments fundamentally alter this process. Your brain is now exposed to unprecedented levels of novelty, stimulation, information density, and reward variability. Short-form content, rapid scrolling, notifications, multitasking, social comparison, endless entertainment, and continuous digital stimulation repeatedly activate dopaminergic reward pathways. At first, this feels energizing, but the brain always adapts. The nervous system is designed around homeostasis, meaning it constantly attempts to maintain balance despite changing stimulation levels. Now, this creates downregulation. When dopamine spikes occur too frequently, dopamine receptor sensitivity gradually decreases to stabilize the system. This means stronger stimulation is required to generate the same motivational response. This process is similar to tolerance. Now, ordinary experiences begin producing weaker reward signals. Activities that once felt meaningful now feel emotionally flat. This is not because life objectively changed. It is because the reward system changed. Now, let's connect this to attentional systems. Human attention evolved for depth, environmental awareness, and sustained engagement. But modern stimulation trains attentional networks toward novelty detection and rapid switching instead of deep focus. Now, the salience network becomes involved. The salience network helps determine which stimuli deserve cognitive resources and emotional importance. Under constant novelty exposure, the brain becomes conditioned to prioritize rapid, high-intensity input. Slower experiences lose salience. Reading feels harder. Conversations feel less engaging. Creative effort feels exhausting. Now the brain begins associating meaning with stimulation, intensity rather than emotional depth. This creates attentional fragmentation. Now let's connect this to stress neurobiology. Under chronic stress, the hypothalamic pituitary adrenal axis remains activated longer than normal, increasing cortisol exposure and altering reward-related neural circuitry. Chronic cortisol dysregulation affects dopamine signaling, emotional regulation, hippocampal function, attentional stability, and motivational systems. Now the brain shifts toward conservation. Motivation decreases. Curiosity weakens. Exploration declines. The nervous system begins prioritizing survival efficiency rather than emotional engagement. This is adaptive in dangerous conditions, but destructive when prolonged. Now let's discuss emotional blunting. Emotional blunting occurs when the nervous system reduces emotional intensity to manage chronic overload, stress exposure, and excessive cognitive demand. This creates numbness. Now, emotionally meaningful experiences produce weaker responses. Music feels less emotional. Achievements feel temporary. Social connection feels draining. and excitement fades rapidly after stimulation ends. Now, many people interpret this as personality failure, laziness, depression, or lack of discipline. But neurologically, the issue is often dysregulation rather than absence of character. Now, let's discuss anhedonia. Anhedonia refers to reduced capacity to experience pleasure, motivation, emotional reward, or anticipatory engagement. Importantly, anhedonia does not always appear as severe depression. In many overstimulated individuals, it appears subtly. People continue functioning, continue working, continue consuming stimulation, but internally, emotional engagement weakens. Now let's connect this to prediction systems. The human brain constantly predicts future reward value. When reward prediction repeatedly fails, meaning stimulation produces temporary intensity without lasting fulfillment, the brain gradually lowers anticipatory motivation. Now, the brain stops expecting satisfaction. This is why chronic overstimulation often produces emotional emptiness despite constant entertainment. Now, consider cognitive fatigue. Under chronic attentional fragmentation, unresolved input accumulates in working memory systems, increasing mental load and reducing cognitive efficiency. Your brain becomes overloaded, not because it lacks ability, but because it never fully disengages. Now, the default mode network becomes relevant. The default mode network is associated with internal reflection, autobiographical processing, emotional integration, and meaning construction. But constant stimulation suppresses this network. Your brain loses opportunities for emotional integration and psychological consolidation. Now experiences become shallow. You consume more, but process less. Now think about modern life. Humans now experience more stimulation in 1 week than earlier humans experienced in months. But emotional fulfillment has not increased proportionally, because stimulation and meaning are neurologically different processes. Now here is the key insight. The brain was designed for meaningful reward, recovery cycles, sustained attention, emotional processing, and environmental balance. It was not designed for permanent novelty exposure. And when the reward system becomes chronically overloaded, the brain protects itself by reducing sensitivity. This is why emotionally exhausted brains often feel numb rather than emotional. Now, what happens if this continues long-term? Motivational systems weaken, attention span decreases, emotional resilience declines, curiosity fades, and eventually, the nervous system enters low engagement mode, where survival and efficiency replace exploration and meaning. Now, how do you reverse this? First, reduce overstimulation. Lower novelty exposure allows dopaminergic sensitivity to gradually recover. Second, rebuild sustained attention. Longer uninterrupted focus periods retrain attentional systems toward depth rather than novelty. Third, restore recovery cycles. Exhausted nervous systems cannot generate motivation effectively. Fourth, tolerate temporary boredom. Dopamine recalibration initially feels uncomfortable because the brain expects constant intensity. Fifth, rebuild meaningful reward pathways slowly. Consistent, emotionally relevant behaviors restore anticipatory engagement and behavioral reinforcement. And finally, understand this. Your brain is not broken because it lost interest. It may simply be overwhelmed by excessive stimulation, chronic stress, and neurological overload for too long. And recovery begins when the brain stops chasing intensity and starts recovering sensitivity again. If you found this helpful, subscribe to Nexplain